So today we are going to do some work on two-step equations, solving two-step equations. What we've been dealing with before were one-step equations, where it was either multiplication, division, adding, subtracting that we were trying to get rid of, and now there's going to be two different operations that we're going to try and get rid of. So let's see how those work and how we would solve those. These are the notes pages that we're on, but actually we're going to come back and do this example number 1 last. So if you can flip over to the next page right here to the top of this, I'll try and zoom in a little bit, where it says solving a two-step equation. This is going to tell us exactly what to do. It says some equations require two inverse operations to solve, or two opposite operations to solve them. Look at this one, how it's written out. 3x plus 4 equals 10. What do you have to get rid of to get the x by itself? Well, here you have to get rid of two different things, right? You have to get rid of 3 times and a plus 4. Two things to get rid of. So we'll get rid of them. The question is just, which one do we get rid of first? And the answer is that since we're trying to get rid of operations or undo operations, we're going to do the reverse of the order of operations. So what usually comes last in the order of operations? We've got parentheses, exponents, adding, subtracting, then multiplying, dividing. No, other way around. Parentheses, exponents, multiplication, division, my dear, adding, subtracting, Aunt Sally. So what's at the end? The adding, subtracting. That's what we are going to get rid of first. We're going to undo that first and work our way up. So can we undo adding 4 right here? How would we undo adding 4? Well, here's our equal sign, right? I'm just going to cross this whole line out. We actually don't need that much space. To undo adding 4, we would subtract 4, right? Minus 4 from both sides. On the left, plus 4 minus 4. See ya, bye-bye. And we'd bring down what we have left. Now in this case, we don't just have x left, we have 3x left. So we would bring that down. And on the right, 10 minus 4 equals 6. So we're not quite done because we don't have the x by itself yet. But now we've got another equation, and this is much more like what we would have had on the hexagonal flower, this 3 times x equals 6. It's a multiplication equation. So to get rid of multiplying, what do? We divide. We don't even need this space down here. You can just say divided by 3, right? Divided by 3. 3 divided by 3 is 1. Bye-bye. Bring down your x. 6 divided by 3 is 2. And that's what we believe our solution is. And we would go back and we would plug it into the original equation to check, just like we've been doing. We'll practice one of those checks in a minute. So what we're going to do right now is just off to the side here, let's recap. Let's write down what our rules were. So here's a big old star. Our rules for two-step equations, there's 2 steps, right? 1, 2. What was our first step that we did? We got rid of the adding. So any situation like this, we're going to get rid of adding, subtracting. We're going to undo addition or subtraction, get rid of the adding, subtracting. Our next step, our second step, dealt with multiplying and dividing. We're going to undo multiplication and division. Oops, division. So those 2 steps, you just have to memorize the order of those for solving two-step equations. Let's see another example of that right down here. See if we can apply these rules to this different looking example. Example number 2. This one says x divided by 5 minus 11 equals 4. We have to get rid of what 2 things? The divided by 5 and the minus 11, yeah. So which one are we going to get rid of first or undo first? Go back to our rules. First we undo any adding or subtracting. So we've got to get rid of or undo this minus 11 first. How do we get rid of minus 11? You got it. Add 11 to both sides. And let's see what that does. On the left, minus 11 plus 11, see ya, bye-bye. You bring down the x divided by 5, because that's what's left. And on the right, 4 plus 11 is 15. Now we don't have the x by itself yet, but we're closer. Now we have x divided by 5. So how do we get rid of dividing by 5? We multiply by 5. I'm not even going to use this extra space they give us. I'm just going to put times 5 times 5. Right? On the left, 5 times 5 divided by 5. See ya? Bring down our x. And 15 times 5, let's see. 10 and times 5 is 50. 5 times 5 is 25. 50 and 25 gives us 75. So that we believe is our solution. Let's look at what a check looks like for this. To check it, we go back to the original equation like we always have been doing, but instead of x, we plug in 75. So let's see. Does 75 divided by 5 minus 11 actually equal 4? Question mark. That is our question right now. Okay? 75 divided by 5. You do it on a calculator, get a calculator out. Does it actually equal 15? What's 75 divided by 5? Yeah, 15. And then we need to go a step further. 15 minus 11, is that 4? Yes, my calculator says yes. Okay. Notice here, guys, when we're doing the check, it's just evaluating an expression on this side, right? We follow the order of operations when we're checking it because we're not trying to undo anything. Sorry, I'll move that up so you can see it. We're not trying to undo, we're just trying to figure out, is that the same? Is that equal? So that's what the check will look like. Okay, let's see if we can do another couple of these to get the hang of undoing adding, subtracting first, then multiplication, division. We're going to flip to the next page. How about if we do number 3? We're going to skip example 3 for a minute and go down to this guided practice. Let's see, how would we solve for a here? We've got to get rid of, here's our equal sign, we've got to get rid of a 10 plus and a divided by 2, right? A 10 plus and a divided by 2. Which one are we going to get rid of or undo first? Any adding and subtracting we've got to undo first. So isn't this really 10 being added? It's a plus 10. How do we get rid of plus 10? We subtract 10. 10 minus 10, won't that be 0? Yeah, that's the whole point. See ya. Bye-bye. 17 minus 10 gives us 7. Bring down our equals. And this time a is not by itself yet. We'll bring down the whole a divided by 2. At this point, a is not by itself still. How do we get rid of dividing by 2? We multiply by 2 on each side. Because over here, times 2 divided by 2, see ya? And you get now a equals, and 2 times 7 is 14. I believe my solution is supposed to be 14 here. Now I'm going to check it just to be 100% sure. Let's write a check. Go back to that original equation way up here and write it out. Does 17 equal 10? What was that, a plus? A is going to be 14, right? 14 divided by 2, question mark. Now, we are going to follow the order of operations to do this. We can't do anything to the 17 or the equals. But right here, we want to see if this is true. Move this up a little. Okay. I'm going to follow the order of operations to evaluate this. I do my division first. 14 divided by 2, get a calculator out. It's going to be 7, right? 10 plus 7. Does that, in fact, equal 17? You can do it on a calculator. Yes. 17, in fact, does equal 17. All right. We're going to do one more. Actually, I'm going to have you, we'll skip number 4, and let's go to number 5 right here. If you're listening to this on your own, go ahead and pause it, and I'm going to have you try number 5 on your own, see if you can apply the same rules to this one. Go ahead, and we'll check it in a second. Okay, let's see how you did on this number 5. We've got negative 8 times x plus 5 equals 29. We need to undo adding, subtracting first. How do you get rid of plus 5? Minus 5 from each side. Bye-bye. I have negative 8x left here to bring down, equals, and 29 minus 5 is 24. Now I've almost got the x by itself. Negative 8 times x. How do I get rid of times? I divide both sides by exactly what I want to get rid of, negative 8. And I get that x equals a positive divided by a negative is a negative 3. Let's see if we're right. Let's go back and check it, and if you didn't do the check on your own, do it now. Negative 8x, it's not going to be negative 83, right? Negative 8 times x. So negative 8 times negative 3 plus 5, does that equal 29? Follow the order of operations. I do the multiplication first. Negative times a negative is going to be a positive. And I can do it on the calculator and make sure that it is actually positive 24 plus 5. Does that equal 29? Yes, 29 equals 29. You can see for these two-step equations that your checks are actually 3 lines long this time instead of 2 lines long. Okay, at this point, I'm going to have you stop this, and we are going to continue with part 2 on a separate video. We'll start off with example 3. So go ahead and find the video called part 2 for two-step equations.